Now that you're experts at simplifying rational expressions, we now want to solve them. We're going to solve both equations and inequalities, and the methodology is different considerably when you're doing an inequality, which we will do at the end. Okay, you've done the equalities many times before. We want to solve for p in this case. We'll notice that we have a number of fractions here. When you want to solve and you have fractions, we know that we always want to try to get rid of the fractions, the denominators, so it's easier to solve. So, however, before you can do that, you'll notice there are several steps here. To figure out the common denominator, you're first going to have to factor the denominators if they are factorable. In this case, only the one on the second term needs factoring. So if we were to factor that one, we would discover that p plus 2 and p plus 3 would factor it. Not a surprise, those are also the quantities in the other two fractions we're looking at. Now, this second step doesn't have to be done now, but I find that if I don't do it now, I forget to do it totally. So, what are the excluded values? What numbers cannot be solutions because they make this expression undefined? Anything that makes the denominator undefined is going to be an excluded value. So what makes p plus 2 equal 0? Well, of course, negative 2. So therefore, negative 2 cannot be a solution. Same way, p plus 3 would equal 0 at negative 3, so it also cannot be a solution, and those would be our excluded values. When we get done, we cannot have either of those as an answer. Okay, now we are ready to actually solve the problem. We need to get rid of the fractions by multiplying through by the common denominator. So what in this case is the common denominator? Remember, it's just like when you were making common denominators when adding. The most you see in any one fraction. So the most I see is of p plus 2s. There is one p plus 2 in each fraction, no more than one, so we only need to multiply by 1 p plus 2. There's also 1 p plus 3 in each of these fractions, so that's my common denominator I'm multiplying by. When I take it times this first fraction, the p plus 2s will cancel. What will I have left? I'm going to just write it out carefully. I'm going to have a 7 and a p plus 3 left. When I go to the second fraction and I multiply the second fraction by those same two, I multiply it by p plus 2 and p plus 3. What's going to cancel? Well, in this case, everything's going to cancel. So I'm going to be left with minus 1. And finally, when I take it times the third fraction, I'm going to discover, trying to find a different color here that will work. See if I can get it to go green. If I multiply this one by p plus 2 and p plus 3, what's going to cancel? P plus 3s are going to cancel, and I'm going to be left then with negative 2 and p plus 2. Now, yes, you could have multiplied those together, and this one was fairly simple, but sometimes you're going to be left with more than one quantity, and you're going to have to FOIL. And I find that if we try to do too much in one step, we cram it all together, and we make careless errors. Now, it's just a matter of doing normal solving for p. In this case, this one didn't even end up with a quadratic. We don't even have a p squared involved. We're going to get 7p plus 21 minus 1 equals negative 2p minus 4. If I combine all my p's, I'm going to move my p's to the left. That's going to make 9p's. On the right here, 21 minus 1 was 20, so I would be subtracting 20. That would give me negative 24. If I divide by 9, that will reduce by 3. I'd be down to negative 8/3 as a solution. Now, what also do I need to do before I can declare myself completely and totally done? Well, yes, I need to check, was that one of the excluded values? In this case, no, it was not. Our excludeds were negative 2 and negative 3. So that is our final solution, p equals negative 8/3. If, for example, and don't confuse this, but if, for example, say you had gotten done and your answers had been p equals 5 and p equals negative 3, then because up above negative 3 was not possible, it was an excluded value, we would throw that out. P equals 5 would be our solution. This would be what we call an extraneous solution. It was a value that makes the equation true. It works, but it's not a possible value. So while it actually does work in the equation, it is not effective because it makes us have an undefined value. So that's solving equal signs. You've done that a lot, so I'm not expecting that to be a whole lot of trouble. Now, you also get to view a few application problems. Some of these you dearly love. And yes, it's back. We've got plane traveling at a certain rate, covering a certain distance in a certain amount of time. And so yes, it's those lovely rate times distance problems. And so the first question would be, what is that formula you know that relates times, rates, and distances? Hopefully somebody out there is saying RT equals D, or some version of this. So yes, rate times time equals distance. Or if I divide the time over, I can say rate equals distance divided by time. Or I can say time equals distance divided by rate. There's many versions of it. So you're going to have to determine which version is right for you. If you'll recall, because this is one that there's a lot of information here, we have a plane traveling, it says 400 miles per hour in still air. It tells us it travels 720 miles against the headwind and then returns back, obviously with the headwind, in a total of 3.5 hours. And it wants to know how fast was the wind blowing. Okay, so what's the key thing we know that relates the going there and the coming back? Since it did two different things, we have to know what relates it. Well, we know that it was going 400 miles an hour plus whatever the wind is, and 400 miles minus the wind. No, it went 720 miles both ways, but the key thing that relates it, it said it's a total of 3.5 hours. So when we get this thing set up, we know that the time has to add up to a total of 3.5 hours. So therefore, that tells me I need to write an expression for time, which means, since I want to end up with an expression for time, I'm using this last equation here, and I want to do distance divided by rate equals time, so that I end up with a time involved in this problem. And of course, I've got two things happening here. I'm going with the wind, and I'm going against the wind. So start filling in what you know. And actually, before you do that, figure out what is x. What is your unknown here that you're searching for? What's the question? The question is, what's the speed of the wind? So that must be what x is going to be. So distances. Does it go the same or different distances as it travels? Well, it goes out 720 miles, comes back 720 miles. The rate is usually your key factor. How fast was the plane flying? It says it was doing 400 miles an hour in still air. On the first part of it, we're going with the wind here. So if I go with the wind, I would have to add the speed of the wind to it. If I go against the wind, I would have to subtract the speed of the wind. Now, use the formula. How do I get an expression for time? And remember, we're studying fractions here. So it says do distance divided by rate, so I would have 720 over 400 plus x, and 720 over 400 minus x. Now, you need an actual equation that you can solve, though. So since you need an equation to solve, what was it that they told you about these times? Sometimes they tell you the difference in the time. Sometimes they tell you they're equal times. In this case, they said a total of 3.5 hours. What does the word total imply? Well, a total implies addition. So in this case, we need to add our two times together. To come up with total time traveled. Okay. Now it's just solving the equation. Technically, we should check our excluded values here. Technically, excluded would be negative 400 and positive 400, but let's face it, realistically, those aren't going to be the answers anyhow. So now, what do I do to actually solve it? What's my common denominator I'm going to multiply by? Yes, it's the 400 plus x and the 400 minus x, which means this could get a touch messy. When I take the first fraction times both of those, the 400 plus x is going to cancel. I am going to be left with the 720 times the 400 minus x. Okay, obviously then when I do the other fraction, I'm going to cancel the 400 minus x, and I'm going to be left with the 400 plus x. Key thing is, do I have to multiply by the 3.5? It's not a fraction. And the answer is, of course, you have to multiply every single term through, so I'm doing it times both 400 minus x and 400 plus x. Well, this one's a touch messier than the last one, and kind of big numbers. So you may have to pull out a handy-dandy calculator here to root out some of these numbers. And in this case, when you multiply this, 720 times 400, oh, boogers. No, 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 no. Well, okay, Mrs. Meyer screwed up her problem. This wasn't supposed to be 400 miles an hour. It was supposed to be 420 miles an hour. And unfortunately, if I don't change it, it's going to make our algebra nightmarishly bad, and that's really not my purpose here. So let's go make this 420s every time. We got 420 plus x, 420 plus x, 420s, 420s everywhere I go. And most importantly, down here, I'm going to have 420s. So I'm going to have my mistake and my apologies. So sorry I changed the problem in the middle of creating it and didn't catch that I had changed those actual values. So now if we try that again, we'll get at least a reasonable answer considering the algebra we're about to do, because when you multiply those, this is really big numbers. We're going to get 302,400 minus 720x. And then we are going to get 302,400 plus 720x. And then the most fun of all, how do I do this right-hand side? Yes, I have to FOIL that. Now notice that's conjugates, so I get to shortcut by taking, once again, 420s, sorry, 420 times 420 here, in which case that makes that 176,400 minus x squared. And so when I actually look at this then, I'm going to have, if I add up the like terms on the right-hand side, or excuse me, left-hand side, look, 720s are gone, the 720x's, but I have to add those constant numbers together. So that's going to give us 604,800. On the right-hand side, I need to distribute the 3.5, which gives me 617,400 minus 3.5x squared. Well, the good news is there's only one x in the whole problem. So we aren't going to have to try to factor this thing. We can just solve for x. I'm going to add it over here to the left side to make it positive. I'm going to subtract 604,800 to the right side, which will leave me 12,600. And then if I divide by 3.5, I'm down to 3,600. And whew, yeah, it's looking like a decent number here. So I'm going to end up with x equals 60. Technically plus or minus 60, but we're talking about speed of the wind. We don't usually make a direction, so we will be going with just the plain old 60 miles an hour is how fast the wind, this particular wind was moving. Sorry about the error in the numbers on that one, but that's your basic fun and exciting problem. I even had the 720s. What did I do? I did write 420 up there. You all were probably screaming at me the whole time going, you're writing the wrong number, weren't you? Once again, sorry about that. Okay, last one. Those of you who have had pre-calc have seen this before. Those of you who've only had Algebra 2, you have not seen this before. Okay, this is not a hard method, but man, I can't get people to remember it because you are so, well, let's face it, we've trained you to multiply through and cancel your fractions, and now I'm going to tell you not to do it. And there's a big reason why. I'm going to look over here at this nice little inequality I've got, 1 over x is less than 2. Okay, if I was going to solve that by trying to multiply by the common denominator, I'd be multiplying by x. But when I do that, Okay, you have to remember you're working with an inequality. On inequalities, we have to watch the inequality, and if we multiply by a negative number, we have to switch the sign. If I multiply through here by x, do you know that x represents a positive number or a negative number? You have no idea what x represents. Consequently, maybe the equation should be 1 is less than 2x, just as written, but maybe I'm supposed to be switching the sign. I'd never know because I do not know what number x represents. Consequently, you can never multiply through by a variable. Never multiply an inequality by a variable. You don't know whether to switch the sign. It's huge. In fact, it's so huge, it's even worth my taking the time to go get the cool creative pen. And I guess since we're in snowflake season, we'll do a little snowflake outline. Never multiply an inequality by a variable. Bad, bad, bad things will happen. Actually, unpredictable things will happen. So consequently, you're going to follow this lovely set of steps I have up here. Not a bit difficult, and I know you're excited to see step 3. Love to test points. But if we're going to have to test points to solve this, testing points only works with positives and negatives. And so if you got to figure out where things are positive and negative, you have to know whether things are above 0 or below 0. Consequently, your first step here is to get this whole thing equal to 0. Now, it's a matter, you have to move them to the same side. Normally, it doesn't make a difference, but I will tell you on this one, there's definitely an easier way to move it. Should we move it to the left or should we move it to the right? Well, do I have to subtract that quantity on the right, which has 2 terms in the numerator? Or would I rather subtract the one on the left, which only has a single 1 in the numerator? When you know you're going to have to subtract and you're going to have to distribute negatives, this would be far simpler if we actually move this thing all to the right-hand side. I know that's weird, but actually your algebra will work easier and you'll have less mistakes. So you've got x minus 2 over x minus 7. I'm subtracting the 1 over x plus 5. Okay, now you literally have to make a common denominator. Well, okay, obviously it's got to be x minus 7 and x plus 5. So the first fraction is missing the x plus 5, so we're going to multiply it, of course, by x plus 5. And oh great, we get to FOIL it together, hot dog. That's going to make x squared plus 3x minus 10. And then on the left side, I'm going to have to multiply it by the missing x minus 7. Okay, what am I multiplying by x minus 7? Am I multiplying 1 or negative 1? And as, of course, yes, you have to distribute the negatives, so that makes that a negative x and a plus 7. That's key, key, key. Now, add it all together. We actually have x squared plus 2x minus 3. That's not so bad. Over x minus 7 and x plus 5. Now you know this expression, and since I have the inequality written backward, if that's bugging anybody, is this expression supposed to be greater than 0 or less than 0? It's on the side, the expression is on the greater than side. If it's really bothering you, you can flip the whole thing, switch sides, put the fraction over here, and then change it to a greater than 0. I don't care. But you have to realize you want this thing to come out greater than 0. So if you want it to come out greater than 0, does that mean you want positives or negatives? And of course you want positives. Okay, we need to test points on this whole expression, not just the denominator or just the numerator, but the whole ball of wax. Okay, to test points, we know we need numbers on the number line, which make each part of this equal 0. Well, the bottom is conveniently already factored. But the top, we need to know where it equals 0, so we also need to factor it. And conveniently, it factors with x plus 3 and x minus 1. So now, how many numbers will we have on our number line? Well, since we've got 4 quantities, we're going to have 4 numbers on our number line, and you need to get them on in numerical order. So the top x plus 3 is going to equal 0 at negative 3. The x minus 1 is going to equal 0 at 1. We're going to have, that was kind of far out. I need to conserve a little space here. Let me move that over. Then I'm going to have a positive 7 out here and a negative 5. So be sure you get the numbers on the line in numerical order. That's really crucial. And by the way, I also, once again, sorry, I'm changing the problem midstream. I want this baby to have equal signs because I need to prove a point about equal signs as well. So let's put an equal sign in all that. Okay, you're ready to test points. Do you know if this thing's going to alternate? And out there somewhere, somebody's saying, yes, Mrs. Meyer, it's going to alternate because all of them are x to the first power. So yes, we only have to test one location. I vote we test 0, which would fall in this interval. If we test 0, we'd have a positive times a negative over a negative times a positive. Grand total, that all makes a positive. Since we know it's going to alternate, we can go a negative and a positive. And we got a negative and a positive. So we actually had 5 intervals there. Okay, which ones are you looking for? Well, we said we wanted this thing greater than or equal to 0. So we are looking for the positives. So we have now determined that we want these guys out here, the guys in the middle, and the guys on the end. But this is the reason I changed it to an equal sign. How do you decide if you want brackets or parentheses? Well, you'd probably inclined to say, well, she made it an equal sign. It's going to be brackets. But it's just like when we very first learned to test points. You can never have the numbers that make the bottom equal 0 because it would make it undefined. So 7 came from the bottom. That has to be a parenthesis. You cannot equal 7. It would make it undefined. Negative 5 came from the quantity on the bottom. That's got to be a parenthesis. You can't equal it. So actually, the only ones that can have brackets are the ones that are on top, which happen to be on this middle interval. They can equal 0 because you can have 0 in the numerator of a fraction. Finally, then, you're going to write out your final answer in interval notations. So we'd have negative infinity to negative 5 parenthesis, unioned with negative 3 to positive 1 bracket, unioned with 7 to infinity parenthesis again. And so that is quite a solution with a lot of parts. It's not that difficult. I did a more challenging one here so you could see one with a little more challenge. If you simply will follow these steps without fail and obey them without fail, you'll be fine. If you choose to go your own way and not pay attention, you're going to crash and burn this horribly, because when people don't pay attention, they multiply through, they cancel the fractions, all they end up with, if you can't do that, you're going to end up with this x squared plus 2x minus 3. You're going to solve just the top part, and you're going to totally miss the whole bottom issue. You're going to be way short of intervals, and you're going to miss a lot of points. So, can't tell you how much this one is a my way or the highway deal. Follow the 3 rules. Mission critical. Okay, good luck. Please ask questions if you're stuck on something.